Good afternoon, everyone. Today we will solve Riemann sum example and talk a little bit about the fundamental theorem of calculus. Today is the last recitation lecture. Today is the last recitation lecture, but we didn't solve everything. So if you want, uh, where is the name? So if you want, I can give you next week one more lecture. We solve more problems. But if you want next week, it will be optional. There will be no attendance. Okay. So if you have questions, we can also join next week and solve more problems from the fundamental theorem of calculus section. Okay. Because today when we solve the Riemann sum example, it will nearly take 35 minutes. So we may not have enough time to solve more examples for the fundamental theorem.
Professor,
Yes.
I have one question right now
Yeah.
about Newton's method.
Newton's method.
Yeah, it's a small question.
Yeah.
For example, if I get a question like ln of x is equal to 1 by x minus 3,
So
how should I equate it to 0? Like,
ln x minus
is equal to,
is
yeah,
equal to what?
1 by x minus 3.
Yes. So what's your question about
Like,
it?
like what I thought was I would just take x minus 3 or on the other side and then subtract it by 1 and equate it to 0. But then when I checked the official example, they just took the whole term to the other side instead.
Yes. You take one of them to the other side. You subtract this to both sides, or you subtract ln x both sides. So for example, you can have the function to be f of x equals ln x minus 1 over x minus 3. This is one way.
Yes, Professor.
The other way, 1 over x minus 3 minus ln x. So this or this, as you like.
Uh, Professor, what about if I do ln x into x minus 3 minus 1
So ln x, then what?
into x minus 3?
Multiplication.
Yes,
Oh yes, you can do that. But
minus.
but now it will
Yeah,
be
it is more complicated.
it will
But
be
I just wanted to know because I wasn't sure if this format would also be correct.
yeah. So in fact, we have three ways. You can do this one if you want, but now you have the
Product
equation
rule, I
equals one.
use. So I can just bring 1 to the other side, right? And then just subtract it by 1.
Oh yes, you can also do that. So you have nearly more. You have nearly four or more ways to write the function.
Okay. I thought it was something about an order.
But but in the quiz, it's clearer than this because as you see, for example, I didn't put a question like this one because as you see, you have a lot of ways, so it's not good to include it. I mean, maybe you have correct idea, but it's not in the options, for example.
Yes, Professor.
But I think there is a question about something similar but clear. I mean, we explained it in the video, so you need to solve it. I mean, there are things that they are clear. This one is not clear because you have many choices. Anyway, let's get back to Riemann sum now.
Professor,
Yes.
definition-based questions.
What?
Are there any definition-based questions, or it's just solving questions?
I cannot tell you what is in the quiz, right?
Okay.
Let's now solve the Riemann sum example because it's important. So let's start here. Remember to write your names and the student ID, okay? So we will use Riemann sum and the definition of definite integral to evaluate integrals. Recall that if f is integrable on the closed interval ab, then we have this integral a to b f of x dx equals limit as n goes to infinity of this summation I equals 1 to n delta x f xi, where delta x equals b minus a over n and xi equals a plus I delta x. Now let's see here. I will use red. Now let's use blue. Yes, for example, if you have this function, okay, I want the area between a and b, okay. We don't have formula for this. We don't have area formula for this. So what can I do? I can divide it into rectangles, right? Yes, let's continue. So a, also call it x0, okay? So a equals x0 and b equals what? xn. The last one, okay? Divide it into 4 rectangles, for example. 1, 2, 4, okay? Assume they are equal. I mean the width, assume the width is equal, okay? For each of them. Delta x, delta x, delta x. Okay? We call this one here x1, x2, x3, okay? I will copy it because I want to explain also the right sum. So one of them for the left sum, one of them for the right sum. Let's do the left sum first. You can take the height to be the left point, okay? So here the height is what? The image of x0, right? Then again use left endpoint for the next one. Then the height here is what? fx1, right? Again, same idea. Use left endpoint. You get what? You get f of x2. Then the last one, also left endpoint. It's fx3. No, it's not the last one. No, it's last one for the. It's the last one for the left. If we are using right, we will be using x4, but this one is for the left. So fx3. Now, how to find the area of each rectangle? Width times height, right? So you have the first rectangle delta x f of x0, right? Because it's left sum. Then plus delta x fx1 plus delta x, it's slow, fx delta x fx2, then plus delta x f of x3. So here we are using left endpoints for this one. Now if you use right endpoint, let's see the other one, right endpoint now. So you start at the right endpoint like this. Then right endpoint, right endpoint, right endpoint. Good. What's the height of the first rectangle here? fx1. Here fx2. Please make sure to participate with me when I ask you, okay? Because I like the lecture when we interact with each other, okay? It's better. Here fx2. then f of x3, then f of x4. What's the total of the areas? We add these 4 rectangles, right? The first one, delta x, f of x1. We add until we reach the last one, plus delta x, f of x4. Now let me ask you about the theorem here. This theorem is using which sum, left or right? What do you think?
Right one.
Yes, the right sum. So if we want, we can write it as what? We can write it equals limit as n goes to infinity of Rn, right sum. If it starts from 1 to n, it's right sum. If it starts from 1 to n, right sum. If it starts from 0 to n minus 1, it's left sum. Good? Now we need also to explain this delta x equals b minus a over n, and xi equals a plus I delta x. Let's explain it here. We are dividing it into n rectangles, okay, with equal width, okay? So the width is delta x, okay? If you divide it into n sub-intervals or n rectangles, okay, and they are all of equal width, then the width of each rectangle is what? Just once, yes. So it will be the whole distance, b minus a, divided by what? By the number of rectangles, right? Because I want the width of one rectangle, so you divide by the number of them, right? So in general, b minus a over n. This for delta x. Now the next formula. You start at a, which is x0. How to get x1? You add 1 delta x, right? You get x1. If you add another delta x, you get x2. If you add another delta x, you get x3. If you add another delta x, you get x4, which is b, okay? So more generally, you have what? You have this formula. This you can write it if you want x0. So xi equals x0 plus I delta x. Do you have question? Do you have question about this? Is it clear? Is it good?
Yes.
Okay. We will need this for part D. Where is part D? Part D is here. So we will use it when we reach part D. Now let's start with part A. Consider the function f of x equals 25 minus x squared in the interval closed from minus 3 to 5. Part A, use a Riemann sum to estimate the area under the graph of f between x equals minus 3 and x equals 5. This you call it A and x0, okay? x0 equals minus 3. The other one, xn. In our example, it will be 4, x4, because we are using 4 sub-intervals. And taking the sample points to be left end points. Sketch the curve of f and rectangles that approximate the area. So first, for part A, we are using left end points, okay? Let's start. So what's the formula for left? L4 equals summation I equals 0. If since it's left, you start from 0 because it's left, and you stop at n minus 3. But n equals 4, not n minus 3, n minus 1 I mean. So you stop at n minus 1, but n equals 4. 4 minus 1 is 3, so you stop at 3. Then f of xi, the area of each rectangle, delta x, fxi times delta x. Now let's calculate this. We have x0, right? Let's write x0. But before that, let's start with delta x. Delta x is more important. So delta x equals b minus a. Remember, this b is x4, the last one. B equals 5, okay? So this one is b. So b minus a over number of rectangles, which is 4. Then you have 5 minus 3. Yes, 5 minus 3 over 4. So it's 8 over 4, 2. Then, now let's calculate x0, x1, x2, x3, x4. So x0 equals minus 3. Then you keep adding delta x to get the others. You have x1 equals minus 3 plus 1 times delta x, so minus 3 plus 2, minus 1. Then x2, you add another delta x, which is 2. You get 1. Then x3 equals 3. x4 equals 5. No need for x4 for left sum, but I am writing it because we need it also for the other part, for right endpoints, okay? So write them from the start, it's good. Now, remember your function is 25 minus x squared. Now we find the images of each x value, okay? So f of x equals 25 minus x squared. So start with fx0, which is f minus 3. F minus 3 equals 25 minus 3 squared. You get 25 minus 9, 16. Then f of minus 1. You get 25 minus 1 is 24. Then f of 1 also 24. F of 3 16. 25 minus 9 is 16. Then f of 5 0. So now let's find L4. L4 equals delta x times the summation of the first 4 values, because it's left summation. So let's write delta x. Delta x equals 2. 2 times 16 plus 24 plus 24 plus 16. Then this equals what? 2 times 80. Right? Yes, it's right. 2 times 80, then this equals 160. Are you good with this? Do you have questions? Do you hear me?
Yes, Professor.
Okay. Do you have questions? Is everything good?
I don't have questions.
Okay. See here. Here is the uh, the continuation of the solution, because you also need to sketch the graph and the rectangles. So here the function f 25 minus x squared from minus 3 to 5. Then for rectangles, c equals 0 for left, 1 for right, 0.5 for midpoint. But we are using left, so 0, okay? You get 160. Do you see 4 rectangles?
There's three of them, right?
It seems 3, but they are 4. Do you know why they are 4?
Because one is in the middle over there, but they didn't mark it.
Yeah, the one in the middle is 2 rectangles, but it seems 1 because they have the same height. See, they are both 24, but they are 4. 4 rectangles. You can add more rectangles if you want to get better results. Yusuf,
Yes.
I need your help with part B. We will use right endpoints, 4 rectangles, and then we sketch.
Okay.
So let's solve part B now.
Yes.
Let's copy. We need these things here. They are the
B
same.
minus A over N is the same, yes? Yes.
We copy this and then we start. Do you remember the formula for right sum?
Mm, I don't know if I remember the formula, but I understand it conceptually. So what we have to do, we have to multiply our width, which is for every rectangle 2, should be 2.
Yes. So 2 times.
Then because we use 4 and we use right hand, we ignore the first value, which is 16, and we start at 24. And then
Yes.
plus 24, plus 16, and plus 0.
Yes, thank you. Now we get 2 times 64.
128.
You are good in arithmetic.
Thank you.
Usually people, they don't know even 2 times 3, but you are good.
Thank you.
So 128. So the left sum 160. The right one 128. Thank you, Yusuf. Now somehow.
Yes.
Now we will solve the midpoint.
Okay.
Sorry, before that, I need to show you the graph of the right sum. So the right sum, we are using c equals 1. See here? How
Yes.
many rectangles
Yes.
do you see somehow?
Rectangles.
Yes, how many rectangles do you see here?
3. Right? Is it 2 or 3?
It seems 2, right?
Yeah.
But you have
Yeah,
4.
it's 2.
You have 4.
4?
Yes, I will show you. See here, the first 2, they have the same height.
Can you hear me?
Yes, I can hear you.
Okay.
See here, the first one is bigger than the others. It's two rectangles because they have the same height. They seem 1, okay?
Yes.
See the last one. The last rectangle has height 0.
Yes.
So it's here, but it's height 0, so you don't see it, okay?
Yes. Okay.
Okay, thank you. Now, Ayman, Ayman? Ayman? Ayman Shad? Okay. Next we have Ayan. Ayan answered me. Then we have Bishar.
Yes, Professor.
Now I need your help with the midpoint. Where is the midpoint? Yes, the midpoint is part C. So again, we have delta x equals 2, we have f of x equals 25 minus x squared, and we have these x values, okay? But now we want midpoint. How to find? But let me draw the real numbers line. So you have minus 3, then you have minus 1, then you have 1, then you have 3, then you have 5. Now I want the midpoints. The midpoint between minus 3 and minus 1. Midpoint between minus 1 and 1. Between 1 and 3. Between 3 and 5. Do you know how to find the midpoint?
I mean, just add the 2, divide by 2.
Yes.
So minus 2, 0, 2, and 4.
Yes, thank you. So minus 2, 0, then 1, 2, and 4, right?
Yes.
Note here that you can also find the first one by adding and dividing by 2, and the others you can add delta x. 2 plus 2 plus 2 plus 2, right? So you calculate them as you like. So, thank you, Bishar. Now Ancient.
Yes, Professor.
What's the image of? I will show you the function, and you help me calculating the images. Okay?
Yes.
I think help me with just the first one. F minus 2.
16.
No, F minus 2 is 25 minus 4.
Oh, sorry.
21, right?
Yeah, 21.
Yeah. Thank you, Ancient. Now Gaia.
Yes, Professor.
What is f of 0? The function is 25 minus x squared. What is f of 0? Do you know the answer?
25.
Okay. Now Ayman Tariq Ismail. Ayman. Ayman. Okay. Ilyas. Ilyas Sharawi. Ilyas. Shahid. Shahid Saraji. Shahid.
Yes.
Thank you. Okay. Gahala Ahmed.
Yes.
Hana Ahmed.
Yes.
Maria Faraz.
Yes.
Shayan Mazhar.
Yes.
David.
Yes, Professor.
Saif.
Yes, Professor.
Shayan. Shahzad.
Yeah, Professor.
Nauman.
Here, Professor.
Ridhima. Ridhima Amin.
Here, Professor.
Faisal.
Here, Professor.
Good. Now again, Ayman Tariq Ismail. Ilyas Sharawi. They are not here. So Ayman Tariq Ismail is here. What about Ilyas? Ilyas Sharawi? If your mic is not working, write me, okay? As Ayman and Shad, they sent me. Ilyas. Let's continue here now. So f of 2, 25 minus 4, 21. Then we need to hurry here. Then f of 4 equals 25 minus 16, 9. Then 2 times, you add these and multiply them by 2. Call it M4, okay? So midpoint equals 2 times 21 plus 25 plus 21 plus 9 equals 152. Good? Yes, it's good. Now let's see the graph of the midpoint. You use C equals 0.5. For this one, it's clear that we have 4 rectangles, right? And the result is 152. Now let's solve part D. Aisha, you are late, right?
I thought there was no class as we have a quiz.
I didn't say that we don't have a class. Now, use the theorem above to find the exact value of the area under the graph of f between x equals minus 3 and x equals 5. So here is the formula. We will use this formula. First, calculate Rn. Then you take the limit, okay? So no need to keep writing limit, no need to write that. After simplifying, you take the limit as n goes to infinity. So let's start. Rn, we want to find Rn. But before that, we need to find delta x and fxi. So delta x equals b minus a over n. b is 5 and n is minus 3, so 8 over n. Then you also find xi. xi equals a, which is minus 3, plus I delta x, which is I8 over n. Then remember the function as f of x equals 25 minus x squared. So f of xi you calculate fxi, you get what? You get 25 minus 3 plus 8i over n squared. Then you get 25 minus parentheses, first squared is 9, then plus 2 times first times second, so minus 48 I over n. Then plus second squared 64I squared over n. Over n or n squared? N squared, right? Next simplify more. You have 25 minus 9, 16. Then minus minus 40i, it's positive. Positive 40i over n. Then minus 64 I squared over n squared. Next we find Rn. Yes, let's continue here. So we have delta x, we have fxi, we just substitute in the formula now. Find Rn. We take limit as in goes to infinity later after simplifying. So Rn equals summation I equals 1, because it's right sum, I equals 1 to n. Then f of xi delta x. Substitute these values. Delta x equals 8 over n, and if xi equals this, I will write it. Summation I equals 1 to n, then 16 plus 48 I over n plus minus 64 I squared over n squared times 8 over n. Then multiply 8 over n inside the summation, okay? You get summation, I mean inside the parentheses, I mean. So summation I equals 1 to n. 16 times 8 over n, 128 over n. Then plus 384 I over n squared minus 512 I squared over n cubed. Close the parentheses now. Then distribute the summation. You get summation I equals 1 to n, 128 over n, then plus summation I equals 1 384 I over n squared, then minus summation I equals 1 to n, 512 I squared over n cubed Are you with me? Do you have questions? Is it good? Now, do you know what's the next step?
There's a formula for n cube, I think, to when you sum it up to infinity.
No, we will not take the limit yet. We will simplify more. I will tell you the next step. Just 1 second. Okay, let's continue. Now you will take things not containing I out of the summation, because see, the variable in the summation is what? I, right? So you can take common factor things not related to I, like 128 over n, and the second summation you can take 384 over n squared out because they are not I. Then the last sum you can take this out of the sum, 512 over n cubed. this we will do it now. So equals 1 to 8 over n summation I equals 1 to n of 1, right? Because if I take 1 to 8 over n out, I am left with 1, right? Then plus the next sum, take out 384 over n squared. So 384 over n squared summation I equals 1 to n I, just I, minus take 512 over n cubed out. Summation I equals 1 to n I squared. What's the value of the first sum? This, what's the meaning of the first sum? 1 plus 1.
It's n.
Yes, it will be n because we are adding 1 to itself n times. So here this is n equals n. The second summation is we are adding natural numbers, positive integers. 1 plus 2 up to what? Up to n. Do you know the formula for this one?
Let n into n plus 1 by 2.
Yes, so n plus 1. Thank you. Divided by 2. Do you know who found this formula for the
Gauss.
Yes. He was very smart. He was kid. His teacher asked them to add 1 plus 2 plus up to 100. He solved it within a few seconds using this formula. So he was very smart. Now what about the summation of squares? This is what you have 1 squared is 1 plus 4. This also has formula, I will tell you. Plus up to n squared. This will be what? This will be n plus 1 2n plus 1 over 6. This is the sum of squares over 6. If you are curious about sum of the cubes, it will be this one but all squared. So n plus 1 over 2 all squared is the sum of the cubes, but this is not important for this example. Now the next step. So you have 1 to 8 over n times the first sum is n, then plus 384 over n squared times the second sum is n plus 1. I really hate this. It's very slow. So n plus 1 over 2 then minus 5 1 over 2 over n square n cubed this time times the sum of the squares, which is n plus 1 n plus 2 over what? Over 6. First we have 1 to 8, just 1 to 8, right? Because n cancels with n. Then the second one, what will we do with the second one? Here you have n times n, and here you have n times n plus 1, right? Give n for each one of them. N for this, n for this. Then here you have 3 n's multiplied, n times n times n. And here you have n times n plus 1 times n plus 2. Give n for the first one. N for the first one. N for the first one. Okay? So 128 plus, but before that, 384 divided by 2, 192. 192. Okay? Times now the n's. N divided by n, 1. Then n plus 1 divided by n, 1 plus 1 over n. Minus, now 512 over 6 is 256 over 3. Now the n's. Give one factor of n for each of these. You get 1 times n plus 1 over n, 1 plus 1 over n. One plus 1 over n. The next one, this one is 2n plus 1, okay? Not n plus 2, 2n plus 1. So you get 2, when you divide it by n, you get 2 plus 1 over n. Now I want to ask you something before taking the limit as n goes to infinity. We got L4 equals, before L4, we got R4, I will write them in order. R4 equals 128. We got M4 equals 152. It's written here. We got L4 equals 160. What do you think? Which approximation is better? What's your guess?
Left.
So you choose left.
Because it's closer to the midpoint.
No, you compare the three of them, I mean.
Oh.
So you,
Okay, then probably midpoint.
so midpoint is better, right? Is the best among them.
Yes.
Midpoint, then left, then right. For this example, I mean.
It's my guess, yes.
Yeah, let's go now find the exact result. We are at the last step. We just want to take the limit as n goes to infinity. So now is the exact value of the area. A. What's the problem here? Yes, so A equals limit R of Rn as n goes to infinity. What's the result for this? Rn is here. So this equals 1 to 8. Limit of constant is just the constant. What's the limit of the second term?
192, because the 1 over n goes to 0.
Yes, thank you. So 192. The third one, here 1, right, because 1 over n is 0. Here 2, because 1 over n is 0. So 2 times 256 over 3. So we got 5, 1, 2 over 3. Then when you simplify, you get 149.3 repeating. Okay? So midpoint is really the best one among them, because the midpoint is 152, using just for rectangles. So midpoint is very good for this one. Left is closed also, it's 160. Right endpoint was very bad, because the error is nearly 27. We'll solve the last part before we stop, okay?
Can I ask a small question about Newton's law? Or
Yeah,
method?
but I will finish this one fast. It will take just 1 minute or 2 minutes.
Okay.
So this one, using the fundamental theorem of calculus, we will get the same result. But how to find this? You find the antiderivative. The antiderivative is what? 25x minus x cubed So x cubed over 3 from minus 3 to 5. I will tell you how to calculate this. So first you substitute 5, the upper limit, open parentheses, substitute 5. You get 5 times 25, 125. So 125, then minus 5 cubed over 3, 125 over 3, which is 41.6 repeating. Then close the parentheses. Then minus, open the parentheses, substitute minus 3 now. You get minus 75. Then minus 3 cubed is minus 27, and you have minus, it's plus 9. Plus 27 over 3 is 9. So you get this. You get the first parenthesis, the value is 83.3 repeating. So yes, good. 83.3 repeating plus 66 plus 66. You get 149.3 repeating. So this is easier, right, than the limit of the right end points. We get the same answer, so everything is good. Do you have questions about this, about fundamental theorem or Riemann sum? What's your question about Newton's method?
We solved the question, which was cosine x equals x. The question is, how do I define if it's x minus cosine x or cosine x minus x?
You decide what you like. Both of them work. You can choose f of x equals cosine x minus x or x minus cosine x, as you like.
It won't give me different values.
Yes, it will be correct if you use any one of them. X minus cosine x.
Okay. You asked me the last recitation. Which recitation did I have a technical issue in? It was in 23rd February.
Yes, last time time really is really very fast, because I still remember that I told someone to remind me. So it's the 23rd of February.
Yeah, I remember the first week when it was Ramadan and we got online.
Yeah, please send me email, okay? Because it's written on attendance paper, not on my computer. So I need to write your name on in the paper, okay? So please remind me by sending email, okay? You are Hana Ahmed, right?
Yes.
Very fast. Send just your name and student ID. I will write it myself when I get back, okay?
Okay.
No, it will be in your just section, because this quiz is just for you.
Professor, do we have recitation next week or no?
Today is the last recitation, but I suggested that since we didn't solve all questions, that it's optional next week if you want. I will open lecture, but you can join if you want, as you like, in case you have questions.
Okay, Professor.
Uh,
The quiz will open at 6 or is it open now?
the quiz. The quiz.
Yes, okay.
The quiz
When will the
after
quiz be
5
open?
minutes.
6?
At 6.
Okay.
Yeah. Do you have another questions?
Professor, I have a question.
Okay.
Do we need an extra camera or something like that? Is there any special rules for this quiz?
No, just look down browser.
All right, thank you very much.
You're welcome.
Professor, can we leave?
Oh, yes, you can leave.
Okay.
Is Elias here? So Elias is not here. So now after Ayan, be sure to Ayman Tariq Ismail. Is Elias here? Elias didn't answer. So skip Elias. Now Shahid Saraji to Maria Faraz. Shahid to Maria. Then Shayan Mazhar. Shayan Mazhar David to Shayan Shehzad. Then Nu'man to Faisal. Now Dahya and Aisha.
Well, Professor, is it okay if I leave the call to go do the quiz?
Ah, yes, you can leave.
Okay.